Okay, problem number 3. On May 4th, Simon A, we got the schools that receive funding based on how many people attend school. Determine blah, blah, blah. The daily number of absences at high school is normal with a mean of 120, standard deviation of 10.5. If the school has more than 140 students absent, they're going to lose funding. What's the probability they'll lose funding? Just a straightforward normal CDF problem. More than 140, so 140 to infinity, mean of 120, standard deviation 10.5, 2.84%. The Principal Association suggests that instead of choosing one day, it's a little like extreme, right? You never know what's going to happen, that they should take 3 days and find the average of those 3 days. So then the question is, what's going to happen to that probability? You can do the math again if you want. It just changes the standard deviation, right? It's now a 10.5 divided by root 3. But what's going to happen is that standard deviation is going to be smaller, which means we're going to be more standard deviations away from the mean, so there's less probability out to the right. So it's less likely for them to lose funding. And you could just do the math again. I didn't do it to find out what the actual percentage, but they want a better explanation rather than just math. And then part C says a typical high school week consists of Monday, Tuesday, Wednesday, Thursday, and Friday. Thank you. They believe the number of absences is greater on Mondays and Fridays, probably true. So they don't want to pick those days. So they say if a school day is chosen at random from 3 typical weeks, what's the probability that there's no Tuesday, Wednesday, Thursday? So success in this case would be picking a Monday, Tuesday, or Wednesday, 3/5 chance. Failure is 2/5 chance. We want 0 successes, so no Tuesday, Wednesday, Thursdays in 3 trials. So it's just 2/5 to the third power, right? It's 2/5 to the third, 3/5 to the 0, and 3 choose 0. So 6.4%. This is the way funding works for most schools. I won't bore you with how funding works for our school. It's different in our school. It's not based on attendance. So another lesson for another day since we don't have time now. Problem number 4. 25th reunion problem per party. An inverse informal survey director asked 50 people their incomes. There were 190,000. They said, hey, yeah, we're doing great. Probably don't want to ask people at the celebration anyway, right? Because they're more likely to have been successful, more likely to be there. Was the whole underlying thing here. It says, what statistical advantage is there to using the median instead of the mean? The median is a better representative of the center for anything with money because of the possibility, more likely, or likely, that it's skewed right. So the mean is going to be pulled by the outliers. So the median is a better gauge of the middle. And then they gave you these 2 methods for sampling. One is to send out emails to everyone and then take the responses you get back. Voluntary response, convenience method. They think they're going to get 600 people that way. The other way is to pick a simple random sample and then call them and make sure you get an answer. The simple random sample is always better, right? Because it's more random. More likely not to overrepresent or underrepresent. The idea here is if you do this email back, more likely the people that are email back the people that are more successful, which means your average is probably going to be too high. You want to mention what's going to happen, but it's going to be too high. You might lie too, just say I'm doing better than I really am, which would also, so that's an acceptable answer also, I think. That would also raise that average. So that's it for 3 and 4.